I'm Kayla Neuman. I work at the State Lab of Hygiene. We're located over on Agriculture Drive. And this is our facility. We have just one section is the forensic toxicology section. We have right up the hill is the Department of Agriculture. We're kind of in the middle of the hill over there. So my section is kind of where the flagpoles are and the windows on the bottom. So that's as much as the forensic toxicology section takes up of our entire lab. Within the toxicology section, we have about 20 employees. We just had our manager's 1-year anniversary there. And then we also have 2 supervisors that supervise the chemists. One does the advanced chemists and the other does the senior and entry-level chemists. And then there's 13 chemists total that do alcohol and drug testing. And we have 1 laboratory technician who receives all of our samples and opens them and checks them in for us. And then 3 operations program associates, which are our clerical staff, and they enter all of our data and answer the phones and other administrative functions that need being done. We get about 18,000 samples a year, including operating while intoxicated and medical examiner, death investigation, and motor vehicle death cases. Every year we get about 4,000 subpoenas from every county in Wisconsin. And last year we testified in 281 trials and logged about 44,000 miles in court travel. And we went to Waukesha County the most last year. Our section, the toxicology section, is accredited by the American Board of Forensic Toxicology. They basically set our standards and our operations that we kind of use our standard operating procedures, and we take their guidelines and we input them into our procedures to make sure that we follow everything that they're suggesting that we do. It is not required for a laboratory like ours to be accredited by any agency. Most other labs, like the crime lab, are accredited by what are called the ISO standards through the American Laboratory of Clinical Crime Lab Directors or something like that. I'm not sure exactly the acronym, but so our section is just accredited by ABFT. You don't need to be required by or accredited by both, one or the other, and you don't even have to be accredited by one. So our section of the lab takes samples from law enforcement agencies all over the state. We do alcohol quantitation, drug screening, and quantitation. And then once agencies get their results, they can call us and we can give them a little interpretation of the results. We also interpret results for the people whose blood that we do test. So they'll get their results in the mail and they'll call us and be like, you know, what's ethanol? I don't know what that is. So we'll explain that that's the type of alcohol that you drink, and that the limit is what it says on the report. And they'll ask legal questions too, like is it over the state limit for driving? Most of the time they are, so we'll have to explain that to them. And then we also testify in trials. And then we get coroner's and medical examiner cases, and we also do the same type of testing for them, alcohol, drugs, and interpretation. And then sometimes they'll want us to associate that with how they died, you know, if this was enough to cause a drug overdose and stuff like that, we can help them out with that. So our workload, our total number of samples last year kind of went down from 2013, but we are still seeing increasing in samples that need drug testing. It's starting to be a more prevalent than alcohol in OWI cases. Alcohol is still by far the majority, but we are seeing more and more people driving under the influence of drugs. You can just see here in the chart the number of subpoenas received for 2013 and 14, and appearances, and then miles traveled. So we do log a lot of miles going to court. I'm sure you're familiar with the OWI statutes in Wisconsin, 346.63. I just kind of broke them down a little bit for you. The 346.63(1)(a) is driving while impaired, and then prohibited alcohol concentration and causing injury and impaired in driving while you're underage for alcohol. So each one of these statutes is listed on our submission form that I'll show you later. And generally the agency submitting the sample will check one of those statutes. We use it to ensure that the sample that we're testing is associated with an OWI case. If it's not, we do have to call them, and then the agency is billed for the testing. Otherwise, if it's OWI, it's funded by the state. Then the statutory limits for alcohol, 0 obviously for underage, and commercial drivers while they're on duty, they have to blow a 0. Multiple offenders usually have a limit of 0.02. I did have a case where he was a multiple offender and he was just over the 0.02, so that case did go to trial and he tried to fight that one. 0.04 for commercial drivers when they're off duty and driving their commercial motor vehicle. And then of course 0.08 for all drivers. And 0.15 usually is a PAC that involves if you're convicted with that kind of blood alcohol concentration, you'll have an ignition interlock device installed in your vehicle. And then there's more and more charges as you get higher with blood alcohols and number of times that you get pulled over. I've had a few cases where it's their 10th or more OWI charge. Just a little bit about DUID, driving under the influence of drugs. It's the same statute. It just includes the controlled substance phrasing. And we have a per se 0 tolerance for illegal drugs. Basically any detectable amount of Schedule I drugs or restricted controlled substance drugs, including Delta-9 THC, which is the active ingredient in marijuana, and then cocaine and its metabolite are also RCSs, methamphetamine, PCP, LSD, ecstasy, and the synthetics like synthetic marijuana and the bath salt category. So this is our list of the top 20 drugs that were detected by our lab in 2013. We still see a majority being THC or marijuana cases. And then we have alprazolam, which is Xanax, and morphine. And morphine in combination with codeine indicates to us that it might be heroin. Usually the levels, it's a higher morphine than with a little bit of codeine that indicates to us that it could be heroin. With our drug testing, heroin metabolizes so quickly in the body that we never see the actual drug heroin, but it breaks down into the morphine and the codeine here. There's also another metabolite that indicates that it's definitely heroin that we've started to see with our opiate testing, but it's very rare to see that one. And then the ones in red are also the RCS samples or drugs. And then this is our chart kind of put together for one of our other formal presentations by my manager regarding the number of drug testing samples performed and then our turnaround time through 2014, which we're very happy that the turnaround time has been going down. We have had a backlog for a long time. And now we are full staff and it's starting to decrease, so we're really proud of that. Okay, now for the actual testing process. This is an OWI blood kit, which I actually have a sample if you want to look at. It looks like. It consists of all of the things pictured here, and we have the two tubes for the blood, obviously, and they contain a preservative and an anticoagulant that the lab technician who draws the blood will mix within the mix after she draws the blood. I think our instructions say about 8 times for thorough mixing. Defense attorneys will go after that part too with the lab technician saying like, how do you know you mixed it enough? Or did you shake it really fast? Because you're not supposed to do that. They'll also ask about different things like the wipe that's in there. It does not contain any ethanol. It has a different type of alcohol in it. And there's also the labels in there that have, the lab technician will write down the person's name, and then once we receive the kit at our laboratory, our technician and later us will review the names on the tubes to the name on the submission form that's also in the box. And we'll compare all the information on the tubes with the form and make sure everything is accurate on the form as well. So this is the form that we usually get, and these are fake names. So you watch How I Met Your Mother, you might recognize some of them. Usually it has the agency's information and the subject information, date of birth, sex, driver's license, citation, if there is one. Sometimes we don't, sometimes there isn't one yet, because they need to know whether or not the person was actually intoxicated while they were driving. Lots of times we'll get samples from accidents where they're just checking to make sure that the person is not under the influence, so they'll call it a consent draw. So the person that crashes, who it might be their fault, they'll get their blood drawn and then they'll send it to us just to ensure that that alcohol or drugs was not a factor in that accident. Then it has the section for collection information. That's usually filled out by the medical technician or nurse that draws the blood. And then the officer will select what testing they want done. And most of the time we get alcohol only or alcohol and drug panel. Sometimes if they know it's THC, then they'll select the THC only section. And very rarely do we get cocaine only. But we always do alcohol on every sample that we get, whether or not they know it's there or not. And then we have this section right over from that says cancel drug testing if the blood alcohol is over a certain limit that the agency will specify. Sometimes they'll put 0.08, sometimes they'll put 0.02 if it's a multiple offender, or 0.1. If the blood alcohol level is over 0.1 that we find by our lab, we automatically cancel any further drug testing. We feel that the level of 0.1 is impairing enough for these types of cases. We don't feel that further testing for more drugs is necessary. And then once the samples are received, we'll sign the bottom and date and time. And then we'll fill out any comments that we have about the sample, if the packaging was damaged, if the blood tubes are broken or leaking. We'll write that stuff down. Any other discrepancies, we write down if the name is spelled wrong on the form versus on the tubes. If there's a discrepancy with the birthday, some lab technicians will write that on the tubes. So we'll write that down. Basically anything that doesn't coincide with the tubes and the form, we'll write down on the sheet, because we could get asked about that in court. So this is kind of hard to see. It's basically the breakdown of how we test our samples. It starts with alcohol testing, and then if it requires drug testing, it will go through what's called an enzyme immunoassay screen, which looks for 6 different categories of drugs. This is usually where we divide them. If they're positive for THC, they'll go on for just the THC testing, or if they're positive for cocaine, they'll go on for just the cocaine testing. If neither one of those is there, and they'll have a benzodiazepine, which are like antidepressants or anti-anxiety medications, or there's narcotics like oxycodone, they'll go on for the basic drug screen, which is just another screen. It looks for even more drugs. From there, any drugs that we find in a screen will be confirmed and quantitated with a procedure specific to the drug that we're looking for. So THC has their own, its own extraction, same with cocaine or Xanax or Vicodin. All of the different drugs have their own extraction, and which is why sometimes it takes a long time to test a certain blood sample. Some of them will have 5 to 10 different drugs in there, and each one of those needs to be quantitated. So it takes that much time to go through and do the paperwork and have it reviewed, and then have the final review and the report sent out. So some of those can take up to 6 months to have all those tests done. Once the quantitative test is done, the laboratory report is reviewed and then issued. And like I said earlier, if anybody who receives the report has any questions, they can call us and we'll answer anything that they want to know about the report. And then sometimes the cases will go on to trial and we'll have to go and testify. Okay. Getting more into alcohol testing, we'll see lots of questions from defense attorneys and even prosecutors about is the blood sample affected by the cold, by the heat? No, essentially it's not affected by either one of those. We do have the preservative and the anticoagulant in the blood, so that is helping with keeping the amount of alcohol in that sample at the level that it was at when it was first drawn. So when we open the tubes, every time we do a test on the blood, you'll lose some of the alcohol that's in the blood just by evaporation. It's inevitable. However, the preservative and anticoagulant in there will help to protect against that. We do keep our samples in a refrigerator. It does help with the stability of the sample. It's not necessary, but it does prolong the lifespan of the sample. So, sample preparation, when we're testing for alcohol, this is kind of our entire setup. We have the diluter and the diluent, which is a solution that has an internal standard in it that we dilute the blood sample with into a new tube. We have our vials and our caps. So when we first take a sample off of the blood rotator, we'll break the seal and open the specimen. And then our diluter takes out a small portion of the blood and dilutes it into this new glass vial. And then we seal the vial with a crimp top metal. It's a metal top with a rubber septum in the front, in the metal cap, and the instrument will poke through that rubber septum and get a sample out with a needle through the cap. And then we make what's called a load list, so it gives us all of the samples that we're running in order, and we use that when we're putting the samples onto the instrument and also when we're taking them off to make sure that we're running them in the proper order and we're not mixing them up and reporting samples wrong. The method of testing that we use is called dual column headspace gas chromatography. It's really big words for a very simple concept. This is our entire instrument. On the left is the oven, and on the right is the auto sampler where we load the samples on. So this is the oven. Once a sample is lifted up into this portion, the vials are heated and pressurized, and the headspace portion of our analysis involves when the sample is heated and pressurized, any of the alcohol in the sample will evaporate into the air above the liquid in the vials, and then a sample of the air is used. That air is what is called the headspace. So it's the space between the liquid and the top of the vial. This is the inside. The dual column that we were talking about, there's a column splitter. So when the sample is injected, it'll go down and be split into two different columns. One of them quantitates it, and the other one is qualitative, so just ensuring that what we're looking for is actually ethanol that we're finding. This is the auto sampler. We run 96 vials at a time, 45 samples with each half of run. So we run one tray full in the morning and one tray full in the afternoon, so we can run 90 samples per day. So that's 90 people's blood that we're testing for alcohol in one day. So this is kind of how the analysis works. So kind of self-explanatory based on the picture, but the ethanol samples, when it's heated and pressurized, will evaporate into the air and kind of equilibrate with the liquid in the air, and then we can get an accurate ethanol reading from the air sample. This is the chromatography that we see for each sample. So one of these sheets prints out for every single sample that we run. We run every sample in duplicate, once right after the other. Our quality control standards make it so that the error rate is 5%. So each duplicate sample needs to be within 5% of the other one, otherwise we'll retest it. So this top graph is from the first column that quantitates the amount of alcohol in there. And then the second one is the confirmation, which is just telling us that, yes, this is indeed alcohol that we're finding. Along with every run, we run a combination standard that has 3 other types of alcohol in it, along with the ethanol. We'll have methanol, isopropanol, and acetone. Methanol is wood alcohol. If you drink it, it'll make you sick and go blind or even die. The isopropanol is rubbing alcohol that you would use within your own household. We actually just had a case where someone was drinking isopropanol to get drunk, and we ended up having to quantitate that, and one of my colleagues did have to go to court and explain how drinking isopropanol breaks down into acetone and kind of compare it to being drunk with regular ethanol. This is the laboratory report that we send out with all the results on it. This one just has alcohol on it. It's kind of cramped together. This is our new system that we're still getting used to. So the alcohol result is right in the middle. It has all the details of the sample on it. Has the sample number, which is a FX number is what we call it. Every sample gets one of those numbers when it's checked in. It has the collection date and time, the condition of the sample when we receive it, usually labeled and sealed. And then it also lists the date of alcohol analysis. If there were any drugs found, they would be listed after the alcohol result. Once the alcohol is tested for in every sample, we'll send out a report with that result or not detected. And then we'll also add a comment that says, further drug testing will be done on this sample and you'll get another report when it's done. And there's the result. Okay. So more into the nitty-gritty of the alcohol. These are just some definitions that I laid out. Toxicology is study of drugs and poisons. And pharmacology is the science of drugs. So their composition, their uses, and effects on the body. Then pharmacokinetics is the action of a drug in the body, action of the body on the drug. So absorption, elimination, metabolism. And then pharmacodynamics, the action of the drug on the body. So what the drug does to the body, like depresses the system. So you'll have a slower heart rate, you'll have slow reaction time, you'll be sleepy, effects of alcohol. And that classifies what type of drug it is. This is just I think it's a PDF file that you can download from this website that has good questions for prosecutors to ask about pharmacology and different alcohol topics for being in court. I think I've read this, I'm not sure. We do use questions out of this publication to give to prosecutors when they're new or they haven't done an OWI case before, and it kind of gives the natural progression of questions that should be asked of the analyst in the courtroom to get all the information needed for the jury or the judge, and it's kind of just a good resource for us. Okay. So what's in a drink? When we do calculations in court, we talk about standard size drinks, which is a 12-ounce beer of about 4% alcohol, 4 ounces of wine of about 10 to 12% alcohol, and about 1¼ ounces of liquor of about 80 proof, so about 40% alcohol. So each one of these is about the same amount of alcohol in each one. And of course, we'll get this most of the time in court. An officer will pull somebody over and, how much have you had to drink, sir? And they'll be like, oh, just one, no big deal. And then they get out of their car to do field sobriety testing and they can't even stand up. So doing calculations does vary because, of course, being in Wisconsin, we like our alcohol, and the drinks are made much stronger than just one shot of liquor in them. So we do have to adjust for that when we're in court, and we will take into consideration that it could have been only one drink that they had. It was just a very, very big one with a lot of alcohol in it. It's just a quick overview of the pharmacokinetics of alcohol, which is just the absorption and elimination. Alcohol is consumed usually by mouth. We have had instances of people putting it up their butt to get it absorbed faster. They soak a tampon in it and put that in themselves. They can inject it, although it's not recommended. There's so many different ways that people attempt to get drunk without being apparently drunk to people, avoiding the smell of alcohol in their breath, or they're underage, so they don't want to get caught with having the containers in their dorm room or whatever. The people get very creative.
Can I just interject a question there, and I apologize for the crudeness of the question. So if they're ingesting it in some other orifice other than their mouth, if they were pulled over, one of the standard things that's often done in an OWI traffic stop is to do a preliminary breath test. So it wouldn't show up on a preliminary breath test then, because obviously it's been ingested in some other orifice, or am I mistaken in that? Do you know?
That's a good question. I'm not exactly sure.
I mean, you have to be a real hardcore alcoholic, I suppose, to be thinking that carefully about, your planning and how you're going to drink so as not to be detected. But
yeah,
just scientifically, I wonder what the effect of that would be.
Alcohol absorbs into your all the water in your body through your bloodstream or any, through your bloodstream. So, which does include your lungs. So I think it would register on there. It might not be as much. Officers are required to wait 20 minutes before they give the preliminary breath test to make sure there's no residual alcohol in the mouth. So I think it would be pretty similar to that.
Okay.
So because the blood does go to your lungs, so I would think that it would still register on a PBT.
Okay. But it absorbs much, much faster, I think you mentioned. And so I think I've seen or heard things on the radio where people have done, like a frat house or something, did that, and guys die from not realizing how quickly it's absorbed, or,
Yeah.
you know.
Yeah. It unlike your mouth, there's a lot of mucous membranes in your intestines and in the anal area. So the alcohol does get absorbed much quicker because of that.
Sorry to spend so much time on that point, but it's just, I don't know. Let's keep going.
When you consume the alcohol by mouth, it's usually absorbed in your stomach and majority in your small intestine. When you first drink it, there's a process called first pass metabolism that kind of takes out a portion of the amount that you drank, and that portion doesn't even get absorbed into your blood. So when we talk about full absorption, we're talking about maximum absorption based on the amount of alcohol that you consume. So with one drink that you consume, about 10% of the alcohol isn't even absorbed into your system. It's just eliminated immediately. So we do have to account for that when we're doing our calculations. We basically just state the assumption that this is the absolute full absorption that you would have, knowing that not 100% of that alcohol would be absorbed. The blood distributes the alcohol throughout the total body water. So alcohol is not absorbed by fat tissue. It is absorbed in any tissue that has water in it, so muscles, organs, but not in fat. And then it's eliminated primarily by an enzyme that's in the liver and is also excreted in the urine, the breath, and in the sweat. So when we talk about a blood alcohol curve, it plots the amount of alcohol in the blood versus time. And it's kind of a graphical depiction of the changes in the amount of alcohol through either a drinking session or a specific time period that we would be looking at in court. And it's kind of a simplified representation because there's so many different factors that go into absorption and elimination of alcohol. So this is kind of a generalized chart of the absorption and elimination of 1 through 4 drinks. Absorption is the really steep part of the curve that goes up into a point, and then the elimination is the backside that's kind of more gradual. When you first drink your first alcoholic beverage, it's absorbed pretty quickly because there's no other alcohol in your body, and alcohol is a small enough molecule that it will go through the cell membranes into the blood, and it'll kind of equilibrate until there's an equal amount of alcohol in the blood and the water in your body. And it'll kind of go back and forth, and then the more alcohol that you drink, the slower you'll absorb because it's reaching that equilibrium with your body water and your blood. So this is the generalized curve that we usually draw in court or have an attorney draw in court. The absorption phase is, again, that upper side to the peak concentration. So the absorption phase is your body is absorbing the alcohol more than it's eliminating. However, your body is eliminating alcohol as soon as you drink it. And the elimination phase is when your body is eliminating alcohol faster than it's absorbing, or is simply just eliminating, it's not absorbing any alcohol anymore. And then your peak alcohol concentration is the highest blood alcohol level that you'll get to with the amount of alcohol that you drank. So there have been many different studies done on absorption, distribution, and elimination. These are a couple of graphs from a study done in 1985. It shows the variation in individuals with their absorption and elimination rates. This one that kind of just looks like a hump likely had the person who ate a meal while drinking alcohol. Eating food delays the absorption rate and will decrease the peak concentration of alcohol in your body, which is why they always tell you not to drink on an empty stomach. And then this next one is kind of more of drinking on an empty stomach or in a fasting state. And it's a sharp rise in alcohol, but over those 3 hours, you can see that it rises and falls with every probably 10 to 20 minutes. So absorption is the act or process of absorbing a drug like ethanol from the site of administration into the bloodstream. And the rate of absorption depends on many different things. How fast a person consumes alcohol, if they're doing 12 shots in a row and they go boom, boom, boom right down the line, or if they're in a social setting and just sitting there, slowly drinking a beer or a glass of wine. The concentration of the alcoholic beverage is also a big factor. The stronger the alcohol, the slower the absorption rate will be, because that alcohol is kind of almost toxic to your system. So the shock of the alcohol content in your stomach will kind of delay that absorption rate until it's diluted a little bit more by your stomach contents. Then it'll start absorbing a little bit faster. The presence of food in the stomach, like I mentioned. A person's medical history. There have been many different medical conditions that can either speed the process up or slow it down. I know that at the lab we've had instances of gastric bypass that people have tried to use to get off of their OWI charges. Acid reflux has also been another one that's been used to try and fight their charge.
So what's the argument that I had gastric bypass surgery, I really got bad acid reflux? How do they construct that into an argument that...
With gastric bypass, I think it's, I only had one drink, but because I had gastric bypass, my blood alcohol level is artificially elevated.
I see.
So, which really it doesn't happen, because it absorbs the same whether or not you have one drink or 10 drinks. So.
Okay.
And also an individual's body chemistry can also greatly affect the absorption of alcohol. Your body absorbs differently from one day to the next. So if you drank on Monday and then again on Thursday, it's likely that your absorption rate is different on each one of those days. And then they're also different between people too. So my absorption rate would be different from Bill's, which would be different from any one of you.
Is there also some gender difference as well on that issue, or am I missing?
Yes. Yep. The amount of water in your body is kind of the major gender difference. So women have less, so they'll take less alcohol to get to a higher blood alcohol level than men. So the rate of ethanol absorption regards to the time to that peak concentration, a person will usually peak within 2 hours of consuming their last drink, although that's under experimental conditions, so either fasting, not fasting. The scientists kind of play with the variables in those experiments to see, what would happen if they change this or they change that. So a majority of people in a social setting will absorb alcohol within a half an hour and reach their peak alcohol concentration within a half an hour. They can peak before they finish their last drink. So if you're right at the end and you're on your last beverage for the night, you'll probably be at that peak level, and then we'll start eliminating after you stop drinking. You'll have full absorption of alcohol usually within 30 to 90 minutes after you stop drinking, with about 80% of the alcohol that you consumed fully absorbed within the first 15 to 20 minutes. Yeah, so the absorption rate is not linear, so it's not going at a constant rate. You're not absorbing at a constant rate. It's either, it's probably faster than you think it is initially, and then elimination does, a majority of elimination occurs at a constant, almost constant rate. So you're eliminating a specific amount per hour from the body. And then, like I said before, the absorption rate does vary considerably between people, and then with each drinking session the person has. And then with OWI cases, a majority of people are in that elimination phase when they're stopped, which is probably the main argument that we get in court is, when I was stopped, my blood alcohol was below the limit, but my blood was drawn 2 hours later, so I was still absorbing the alcohol, so it was higher when it was drawn versus when I was driving. And then just the effect of food, again, in a graphical representation. The light blue is on an empty stomach, and then the dark blue is on a full stomach. So it really just changes how fast the alcohol absorbs and then that peak concentration. Ethanol distribution. Alcohol is completely water soluble, so it dissolves into all of the water that's in your body. It's distributed by your blood to all of that body water through a process called simple diffusion, which just means that the alcohol moves from a section of higher concentration to lower concentration until it reaches equilibrium and then starts being eliminated. So the effect of alcohol on a person varies with their amount of water that they have in their body. So a male that's 100 pounds will have about 68 pounds of water in their body versus a female that's 100 pounds will have about 55 pounds of water. So females tend to have more fat, and fat tissue does not absorb alcohol. So it'll take less alcohol for a female to get to the same blood alcohol concentration of a male if they're the same weight. So a 100-pound male will have to consume more alcohol than a 100-pound female to reach the same blood alcohol level. And then people of different weights and the same sex. So a 100-pound male will still have that 68 pounds of water within the body, but a 200-pound male will have 136 pounds of water in the body. So it'll take more alcohol for the 200-pound male to reach the same blood alcohol level as the 100-pound male because they have that added water. However, the difference would be if the 200-pound male is overweight and would have more fat tissue, then we would have to adjust our calculation for that factor. So I typically use a body mass index chart and go to the, there's a line that's cuts off the overweight from the obese section, and I'll go right to the weight for a specific height and kind of adjust the weight to make it kind of equivalent to if the person was not overweight. because it takes the same amount of alcohol for the person at 100 pounds who is not overweight to a person at 100 pounds who is overweight. So it's kind of a convoluted explanation, and if you have any questions, I'll be happy to answer them to try and make that more understandable. The process of elimination, when you look back on the graph, is essentially linear at blood alcohol levels over a .02. At .02, it kind of tapers off and isn't really linear anymore. 95% of alcohol is eliminated through enzyme metabolism in the liver. Metabolism can occur in other organs and tissues, like the stomach, and I'm not sure if it occurs in the small intestine, but because of the stomach acid and things like that, the stomach can metabolize alcohol, which is part of that first pass metabolism. So any alcohol that's metabolized in the stomach will not be absorbed into your body. The average elimination rate for alcohol is 0.015 grams per 100 milliliters per hour. That's usually the number that I use in court, 0.015. Some chemists will use a range, the practical range, 0.010 to 0.020. 0.010 we usually use for inexperienced drinkers or people who drink specifically in a social setting, whereas 0.020 we would use for people who are considered alcoholics or heavy drinkers, because their body gets used to metabolizing the alcohol, so it's able to do it much faster than an inexperienced drinker would. And yep, inexperienced drinkers eliminate slower than an average, and alcoholics much faster than average. So when we're in court, the argument that we usually hear is the curved defense. So the defense attorney will likely say, the chemical test, that's accurate, but doesn't reflect the actual concentration in my client's blood at the time that they were driving because of many different factors, including what's called backloaded drinking or bolus drinking, which is having a large amount of alcohol, say like 5 shots, and then immediately getting in your car and you start driving. It hasn't had that time to absorb fully yet. They'll also say post-incident drinking. So if a person crashes, then they're so overwhelmed by the shock of the crash that they walk home and then start drinking. They'll use that as, I crashed, but I wasn't drunk when I crashed, type thing. And then they'll try and say that absorption is delayed by food or fear or shock from an accident or something like that. So ultimately, what they're trying to say is that their client's blood alcohol level was below the legal limit when they were driving, but because the blood test was taken 2 hours, 3 hours later, they absorbed more alcohol within that time period, and it was higher when it was collected versus when they were actually driving.
You did mention food earlier as a variable that could definitely affect the rate of absorption.
Yep.
But these other things, fear, shock, is there any literature or studies that indicate that fear or shock can affect that rate of absorption? That seems kind of a novel argument to me.
I couldn't name any studies, but what I've been told is that it is possible for the body to go into shock, and it will shut down the process of alcohol elimination or absorption to kind of focus on other things. Like if the person was injured, it'll focus attention on the injury versus actually absorbing alcohol.
So you might have a case where the defendant himself or herself was gravely injured, very seriously injured, med flighted to the hospital or something, survived, and are being charged with an OWI-related offense. Okay. I guess I was thinking more of somebody who's just kind of on edge after having been in an accident and not physically injured that deeply. Okay,
Yep.
see.
One of the other things that I have heard too is that my client's blood alcohol level was artificially elevated because they had a big cut on their forehead and they were bleeding a lot. So the amount of blood in their body was less than the amount of alcohol in their body, which is absolutely not true, because the alcohol does diffuse into the entire body water. So no matter how much blood you have, the concentration of alcohol is going to be the same, no matter if you lost some of that blood or not. So this is the graphical depiction of the defense's alcohol curve. So the green dot is the time that they were arrested. This is their theoretical argument that they're doing. And then the test was later, and they reached their peak alcohol level right at the testing. So they weren't as drunk as they seemed when they were driving versus when they had the blood collected. And then this is the prosecution side of the alcohol curve. Which is actually the majority of cases that we see is a person will be eliminating alcohol when they are pulled over, and then will be continuously eliminating alcohol, so the result that we give is actually less than what they actually had in their body when they were arrested.
You could just close that. Sorry.
I've been seeing this more and more. It's called the Hints chart. So there's one for males and one for females. It's kind of difficult to see, but it basically has the body weight on the side and then number of drinks across the top, and it'll estimate a blood alcohol level based on the number of drinks that a person has for their given body weight. And then at the bottom, it'll tell you how it calculates each one of those. So a 150-pound male will effect per drink will be about 0.025. And that is if all of the alcohol in that beverage was fully absorbed at that time instantaneously. So this is just an estimate. In reality, it'll be less than that 0.025. That will be actually in your blood. This is the calculation that they use for that chart. It's based on a guy, his last name is Widmark. He did many, many studies to come up with this general equation of how to estimate the blood alcohol content in a blood sample or a breath sample. So he uses the amount of alcohol in grams over the body weight in grams times the rho factor, which is the based on the amount of body water that you have. So for females, it's an average of 0.55, and for males, 0.68. So basically, the weight of alcohol consumed divided by the weight of water in the body determines the concentration. So the factors for using an alcohol chart to predict the blood alcohol level, you have to take into account many different assumptions when you estimate a person's blood alcohol level, including the actual amount of alcohol consumed. You know, the chart uses standard drinks. When we do our calculations, we use standard drinks also, and that would be that 12-ounce beer, the 4-ounce glass of wine, or the 1 shot of liquor. The body water distribution, so like I said, the obesity, if a person has much more fat than, I don't want to say normal, but if a person is overweight, they would have more fat than that general estimation of the 68% water in your body. So it'll definitely affect your estimate with that. And like I said, I do adjust my calculations if someone is obese by using a body mass index chart. It just seems to be a little bit more accurate than doing it without. And the chart also lists the minimum number of drinks, like I said, to reach a specific blood alcohol level, because not all of the alcohol is absorbed from that one drink into your bloodstream. And then you also have to account for the time factor, including the elimination rate and any delayed absorption that may have happened, or food consumption. And then individual biological variation. So every time we do a calculation, it's based on averages, and it's an estimate for the person. We don't know their specific absorption rate, elimination rate, or we don't really know specifically what they had to drink, because we weren't there observing them when they were drinking or driving. So retrograde extrapolation estimates the amount of alcohol at a time prior to the actual analytical test, or the time prior to when their blood was collected, because our testing finds the blood alcohol level at the time that the blood was collected, not before, not after. We use retrograde extrapolation to estimate the amount of alcohol that was in the person's blood earlier than when it was collected. So essentially, when they were driving, how much alcohol would they have in their body at that time? Why we would extrapolate? The legal requirement being the test was more than 3 hours from the arrest. You have the loss of the presumption. And also post-crash alcohol consumption. So a person crashed their car and then walked home and started drinking.
And just to clarify, that presumption is a presumption of reliability in the test result, or how would you describe that presumption?
The legal, presumption is that the test result is accurate unless the time period between the arrest and the blood draw is more than 3 hours.
Okay.
So, if it's 2 hours after, our test result is essentially what the blood alcohol level would be at the time of driving.
Okay.
Because of that 3 hour, it's within the 3 hour time period. So that's kind of a legal thing.
Right.
And I've gone to court on many cases that it's been less than 3 hours and they still have me calculate backwards.
Sure.
So. And then we would extrapolate based on if the defense pulls the alcohol curve, defense saying that, it was lower than what it was at the time of collection. And very rarely we would do calculations to rebut subject's drinking history, like, say that they were lying because they had to have had more than the 2 that they said they had. Okay, calculations that we usually do in the courtroom. This is the effect per drink calculation. So it kind of estimates per a specific alcoholic beverage what your blood alcohol concentration would be. And again, it's like the chart. It would estimate if all of the alcohol in that drink was fully absorbed into your blood system. So you would take the alcohol dose, so a 12-ounce beer you would pop in there, and the percent alcohol, so 4%, divided by the person's body weight, and then times 19.3. We call it our all-in-one conversion factor. It kind of adjusts for the different units so that we can, what comes out is the grams per 100 milliliters units that we want. And then times the rho factor, which is that 0.55 for females and 0.68 for males. And then we can use our test results and the elimination rate to estimate blood alcohol level at an earlier time. So to do that, we would take our test results, which is the measured BAC, and I generally use the average elimination rate, 0.015 grams per 100 milliliters per hour. and then multiply that by the time difference between the test and the arrest. And then we can estimate a person's blood alcohol earlier. That just gives the elimination range. Sometimes an attorney will have you use the range. I generally use the average. It's much easier to do. And then the time difference, time between the stop and the blood draw, generally in hours. With retrograde extrapolation, we can only estimate based on the information that we're given. So if we're given not enough information or little information or inaccurate information, our estimate is going to be inaccurate or, only as good as what we're given. To make an accurate estimation, we need the analytical result, the time of the test, the time of driving, or we call it the time of violation, is usually what's written on the submission form that we get. And then the alcohol consumption history, including the type of drinks, the time period that they were drank in, so, 2 hours prior to driving or whatever, and then if the person had any food. And also the subject's height and weight, which we use the weight in that calculation, and I usually ask for the height to gauge whether or not the person could be overweight at based on their height and weight, and using that body mass index chart. So things to consider when doing a retrograde extrapolation. We can't stress enough that these calculations are estimates. It's not a scientifically valid number like our test result. The only thing that we know is that their blood alcohol was at the amount that we found on our test result at the time it was collected. That is what we know for sure. So anything else is just an estimate. We have to, sometimes we'll be asked to account for unabsorbed alcohol, which is where that calculation of effect per drink will come into. If they say, they had a drink right before they drove and they got pulled over 5 minutes after they started driving, that drink is still being absorbed. Can you take off that drink? How many drinks would it take to be below the 0.08? So how many drinks essentially would they have had to have slammed before they drove in order to be at this higher blood alcohol level when the blood was collected? To evaluate, again, the amount of alcohol consumed after they were driving, say if they had an accident, we can also use the unabsorbed alcohol to take off a specific amount. So we provide as general estimate as possible. Most of the time we like to just say, they would have been for sure above 0.08 at that time, or they could have been below 0.08 at that time. It's really more accurate to give a general estimation versus an actual number. And again, it's not as accurate as the actual measured blood alcohol level. And when doing our calculations, we do state all the assumptions that we have. Some other calculations that we can do and have been asked to do in court estimate the number of drinks it would have taken to reach the blood alcohol level at the time that it was collected. So if a person is a 0.2 and their effect per drink would be 0.02, it would take about 10 drinks to get there. We've also been asked to estimate the number of drinks needed to be below a prohibited alcohol content, so either below 0.08 or below that 0.15 level. And also estimate how many drinks are needed in a given time period to reach some theoretical blood alcohol level. Who testifies about our calculations? When it's us who tests the blood and we give a blood alcohol level result, it would be one of our analysts, whoever actually tested the blood. blood tests from the crime lab, obviously, are people that tested it from the crime lab. And then if it's an evidentiary breath test that was done, the chemical test section would testify about that. And they can also do calculations similar to what we do for blood alcohol level, for the breath alcohol level.
Do you know why a blood sample would get sent to the crime lab versus getting sent to the state hygiene lab? Is there some sort of protocol that has to be followed in certain types of cases?
Generally, the hygiene lab gets all misdemeanor cases. We do get felony cases, and we are starting to now encourage people to send us their felony cases. But things like homicide by intoxicated use of motor vehicle will generally go to the crime lab instead of us, because of the felony and that higher level of the charges.
Are they doing any sort of different test, though, from you? I mean, is it the same, people are qualified just like in your lab, and the same qualifications in crime lab and hygiene lab, same test,
Yep.
but one sample goes to the crime lab and
Yep.
the other goes to hygiene?
Yep.
Interesting. I'm sorry, I interrupted your train of thought. Or were you pretty much wrapping it?
Yep. I'm pretty much done.
So class, I have a couple follow-up questions, but before I chime in, because I'll talk all day, any questions from you for our guest? Well, let me just ask a few follow-up, and then we'll stop the recording, and then we'll see what we can do with our fictitious numbers and our fictitious case. So you'd mentioned near the outset that the largest number of cases, I think you said, came out of Waukesha County last year, which is interesting to me because obviously Dane is a larger population center and Milwaukee's the largest. Is there any sort of reason? I mean, does Milwaukee send theirs someplace else, or Dane send theirs someplace else?
Waukesha County was the place that we went to most for court testimony.
Oh, I see, for court testimony.
Yeah.
Okay,
We
so,
had a lot of samples from Milwaukee.
Okay.
Yeah.
okay, I misunderstood what you had said, because, okay, that makes more sense to me then. With respect to legal prescription drugs, and I mean, you showed us the numbers, and definitely if we looked over, say, comparing numbers from 1990 to 2014, there'd be even more of a discrepancy between the number of prescription drug type cases. But I think I forgot what the terminology was that you used, but there are a lot of people that are on quote-unquote legal prescription drugs. They've got a valid prescription from their physician, and they're taking the drug as prescribed, yet they still could be pulled over and convicted of operating while under the influence, even if they're doing everything that the doctor's instructions say and they're not exceeding the amount of dosage. Like a drug like, I think you said Xanax, I forgot what the chemical name for Xanax is, could in fact, even if you're doing everything that you're supposed to do according to your doctor's permissions, you could still end up getting an OWI?
Yes.
Okay. And that does happen with some frequency. I think there were like 200 some cases of that last year that you saw.
Yep. It really depends on the level of impairment that an officer saw. So we can go in and testify generally to the effects of a specific drug, but a majority of that type of cases based on the field sobriety test that the officer did, and any video or anything like that.
Because a lot of people are lulled into this false sense of security. Well, because it's a legal drug that was prescribed by my physician and I'm taking it in accordance with the prescription, somehow it's safe, but that isn't necessarily the case. And oftentimes the pill bottle will come with some sort of sticker warning, don't operate heavy equipment or drive within X number of hours of using this drug. Okay. Now, with respect to alcohol, you said at the outset, and you showed us the statutes, usually when people get arrested, and this is probably getting a little bit out of your area of expertise, but for alcohol-based driving offense, a drunk driving, with two different charges, they usually get charged with an OWI, operating while impaired, under sub 1, sub A, and a prohibited alcohol concentration, which is the .08 that we generally think of for most people, under sub 1, sub B. So they get two tickets or two charges, but only end up getting convicted of one of them. Is there such a thing with respect to drugs, like a .08 level? I know that's probably a bad analogy to make, but there really isn't, right? I mean, if you have any presence of cocaine just the fact that it's there, doesn't matter what amount it's in,
Yeah.
results in a conviction if the jury believes all the evidence?
Yes. There's a list of restricted controlled substances that include cocaine or that main ingredient in marijuana, LSD, things like that. If there's any level at all, you can be found guilty of having that in there. So things that don't count would be like the antidepressants and anti-anxiety medications. There's no legal level of having those in your body. It just depends on the impairment seen by the officer.
Right, so maybe you have somebody who reacts differently to the drug, and even if they quote-unquote drive just fine, or at least they're not engaging in a driving behavior that catches the officer's attention, whereas you might have somebody else who just, because of how the randomness of the universe, they just happen to be driving past an officer after they've taken their Xanax or whatever and do something, deviate within their lane or something that gets the officer's attention, and then they have a traffic stop, do the blood draw.
Yep.
There we are.
There are some drugs that will develop tolerances in the body if you've been taking them for a while. Things like opiates, so oxycodone and morphine. People can get used to the effects of those drugs, which kind of gets them in trouble too, because they end up taking more of it because, it's not working like it did the first time, so they end up taking more and more.
Right.
But yeah, you should definitely get used to how your body is when you're on your prescriptions before you even attempt to try and drive.
How often do you see a discrepancy, and I'm switching gears really abruptly here, between the information that's on that styrofoam standard kit and the submission form? I mean, does that happen once in 1,000 cases, once a year, or you know what I'm asking?
As far as like the submission form and like the blood tubes?
Well, I thought that, doesn't the officer have to write something on the kit itself, or am I mistaken? They're only writing on the submission form as to whose blood it is and what time it was taken?
Sometimes they'll write like a case number on the outside of the box,
I see.
but we generally throw the box away.
So all the contact information is on the submission form?
Yeah.
So in terms of then, because defense attorneys understandably are often challenging a chain of custody, so the way it's supposed to work is that, the cop gets the blood draw from I always forget the name of the technical term for the blood draw specialist, thrombologist, what is it?
Phlebotomist.
Thank you. Thrombologist, I don't know where that came from. Takes it from them, seals it, puts it in the kit, seals the kit, and then generally gets mailed into your office, and somebody in your office, one of the 3 support staffers, I think you mentioned earlier, like logs it into a waiting area, a secure place where no one can tamper with it, obviously, and then it gets assigned to the individual chemist for the testing? I don't want to get too technical, but...
Basically, when the blood kit is sealed by the phlebotomist or the lab technician, after they draw it, the officer can either mail it to us. We include a mailing label in the kit, or some send it through certified mail or like UPS. If it's in Dane County, generally they'll just drop it off in person. But then it's received by our evidence technician, and he'll, if he's not working on opening samples that day, he'll put them in our cooler. Otherwise, he'll open them right away and assign them a number. And then if it's our turn to run the analysis, we just go in and we pull out a set of samples, and we basically go over the same information that he looks at and verifying it for ourselves that it's accurate, and then we move on with our testing. So, and all the information from that submission form is put into our computer database by our clerical staff.
Okay. Just 2 more follow-up questions for me, and then I'm going to ask if anybody has any follow-up based upon my follow-up. You mentioned that you always test for alcohol, even if the cop doesn't necessarily suspect alcohol.
Yep.
Is there a reason why you always test for alcohol?
Really, it's just our procedure.
Okay.
It's just how we do it.
Can you use the same sample? So you run the alcohol test first, and then can you use that same sample to do a different type of drug test?
When we run the alcohol test, we take a small amount of the blood out of the tubes that it's collected in, but we use the same blood tubes with
What was left in the
what
tube?
was left for
Okay.
any other testing.
Is that second vial ever used, or you just primarily do the?
Yep. We do, if, most of the time, if it goes on for drug testing, we'll break open the second vial
Okay,
if necessary, but we try and deplete the first vial first, and we do hold on to all of our samples for 6 months after they're reported. So if either the person whose blood it is wants it retested, or the defense attorney wants it retested, or the prosecutor wants it retested, we can either retest it ourselves or we'll send it out for them.
so when you say send it out, where does it get sent out? To a different lab,
Yes.
out of state or something?
Generally, we use one of two labs, NMS labs in Pennsylvania or AIT labs in Minnesota, I think.
Okay,
So yeah, we'll send it to either one of those.
so they obviously perform a certain test at one of those two labs that you aren't capable of performing in-house, or?
If it's alcohol, it's most likely the same exact test that we do. They just, if it's a person requesting to have their blood retested,
I see.
they're like, you tested it wrong, it couldn't have been this high,
Okay, I see.
have it retested by somebody else.
Interesting. Okay. That's it for my questions. Any follow-up to my follow-up? So what we're going to do now is I'm going to stop this and